Pin hapo ianze sasa. So now we start with what? Mathematical calculation involving effective resistance is equal to R1 plus R2 plus R3, where R is the resistor. So this is the formula of resistance in what? In a series. So we write this down. Three resistors of values, 6 ohm, 3 resistors of value 6 ohm, 10 ohms and 8 ohms. 3 resistors of values 6 ohms, 10 ohms and 8 ohms respectively, are connected in series. In an electrical circuit. Are connected in series in an electrical circuit. Full stop. Calculate the effective resistance. Calculate the effective resistance. The effective resistance. So from there we start to do analysis. This one corresponds to resistor what? Resistor 1. We have resistor 2. Then we have resistor 3. Okay. So when we have someone who is able to apply this formula, you substitute the values and get us the final resistance. Let's have someone. Wesley. We substitute the values we have here in the main formula so that we can get the answer, the effective resistance.
Resistance total is equivalent to resistor 1, which is 6 ohms. Resistance total is equivalent to resistor 1, which is 6 ohms. Resistor 2, which is 10 ohms, plus resistor 3, which is 8 ohms. 6 plus 10, 16 plus 8, 24. So the resistance total is equivalent to 8 ohms.
Is it right now?
Yes.
Okay, that is good work. Formula of effective resistance, which means we are connecting the resistors in what? In parallel. So from there we can have just a simple connection. So we have our resistor 1, resistor 2, resistor 3. We connect them in parallel. Parallel connection means we are connecting the path of electric current in one line. It is parallel to the other. That is now what we mean by parallel connection in this case. So all of these we connect them to our power supply. So we have our switch there. We can have our ammeter here. Then we have the power source, where we have used only 2 dry cells. Then we can have our voltmeter here. which is going to give us the total voltage. If we want to get the voltage of each resistor, we will connect what voltmeter in each resistor. We connect a voltmeter 1 there, voltmeter 2, voltmeter 3, for us to be able to get the voltage of each resistor. But now in this case, what will be changed? Voltage will not change because they are connected in what? In parallel. What will change is current. So if the current is changing, for us to be able to monitor, we need to connect an ammeter across each resistor. So here we can have our ammeter here 1, ammeter 2, then we can also have ammeter 3 there. Ammeter 1, ammeter 2, ammeter 3. So that we can be able to know if there is change in of current from R1 to R2 and R3 respectively. So that is the circuit that we can use. So from here, we are saying that Vt is equals to V. Why? Because the voltage remains the same. Voltage remains the same. Because we are talking about parallel connection, and we know that voltmeters are always connected in parallel in a circuit. So we are not going to have any voltage in drop. What we are going to have, it is a change in current. So current changes. Current will change from one resistor to the other. So because of that, we are going now to have our effective total current will be given by current in ammeter 1, which corresponds to R1, then with current in resistor 2 and the current in resistor 3. So from that, we are going to have total current being current 1 plus current 2 for resistor 2, then current 3 for resistor 3. So in this case now, we introduce again Ohm's law. So from Ohm's law, we know that R is equal to V over I, whereby R is the resistance, V is voltage, I is current. Resistance is measured in what? Ohms. Voltage in volts, current in amperes. So from here, are you able to get the formula for current? Yes. You make it the subject in the formula. So what is the formula of current, Charlie?
R of V.
The formula for current will be Formula for current will be what? You multiply both sides by current to get the formula for current. Someone do that very quickly.
I is equals to
Onesimus.
I is equals to V over R.
V over R.
Yes.
Current is given by voltage over resistance. So from there we proceed. Where we have what? Current we substitute. So from there substitute the value of current. So from our main formula, total current is given by current 1 plus current 2 plus current 3 is now going to reduce to what? Where we have current, we substitute. This is total current, so we substitute with the formula for current, knowing that this one will be total voltage, this one will be total resistance. But voltage does not change, so the voltage will remain as V, okay? So here we are going to have V over RT. Total resistance or effective resistance is given by formula for current 1. You use R1 for resistor 1 here. So in this case we are going to have what? V
over R1
plus
V over R2
plus
V over R3
over R3, isn't it?
Yes.
From there you look at what is common. You look at what is common. What is common, mother? From that equation. So we factored V out. So we multiply both sides by V. We multiply both sides by V. So we have V over RT is equal to V over R1, V over R2, V over R3. Multiply both sides by V. Both sides by V, every side. We multiply by V. So this one is going to do what? Cancel out there. The V is going to cancel out. So you'll be left with V divided by V. V divided by V. 1. Yes. It is just like dividing 10 by 10. You get 1. So V divided by V is 1. So we are going to have 1 over RT is equals to V divided by V again.
1 over
1 over R1 plus V. You know here we have not yet multiplied, we have divided. We have divided by V both sides. So when we do division, we get 1. That is why we are getting 1. So we have 1 over R1.
1 over R2.
Then
1 over R3.
R3. So that one now remains as our formula for the effective resistance for the resistors in parallel. So when the resistors are connected in parallel, the formula will be 1 over RT is equals 1 over R1 plus 1 over R2 plus 1 over Rn, where n is an integer. It can be 1 up to any value. So this can be 3, 4, a million, depending on the number of resistors you have. This is now the general formula. This is the main formula if you have only 3 resistors. But if you have more than 3 resistors, you go to the what? Main formula. Because, like for example, if you have 7 resistors, you will not use this formula. You will have to add other resistors to total 7. So that is why up here has the value of subscript n, meaning n is any integer that you have been given. So from there, the next thing it is to do what? The next thing it is to do mathematical problem to be able to prove this working of this formula. But before we do that, let's talk about if, for example, we have only 2 resistors. If we have only 2 resistors connected in parallel, then we are going to have 1 over RT is equal to 1 over R1 plus 1 over R2. So from here, we do the LCM. We do the LCM, the least common multiple. Because we are working with unknown values, LCM you just multiply. LCM or the denominators, you just multiply when the numbers are, when the digits or the values are unknown. So here you are just going to have R1 multiplied by R2, you get what? R1 R2 divided by R1 R2 divided by R1 R2 multiplied by 1 R2 R1 divided by R2. Then there is addition sign here, so we add. So here we have what? R1 R2 divided by R2. So we have R1. All of this is equal to 1 over RT, which is effective resistance. From there now, you know our aim is to get this value. So if you want to get this value, this is a reciprocal, okay? Yes. This for us to be able to write RT, we have to take reciprocal. We have to do reciprocal of RT here. And in this case, a reciprocal of a number is 1 divided by that number. For example, reciprocal of 5, it is 1 over 5. Which in the standard mathematical write-up, you can write it as 5 power negative 1. in terms of indices, in terms of reciprocal. So in this case, to get RT, then it means whatever we have on the right hand side, we do a reciprocal, which is very easy. So the numerator will become the denominator, and the denominator will become the numerator. We will have done the reciprocal. The way we have done here, 1 has become the denominator, RT the numerator. So if we are going to have RT, it is RT over 1, but we don't write the 1. So we are going to have RT is equals to what? R1, R2 divided by R2 plus R1, which can also be rewritten as, after rearranging, RT is equals to R1, R2 over R1 plus R2. That is the formula of any two resistors connected in parallel.